Hello, Calculus. Sorry I didn't make it in today. I had the stomach bug and it's awful. But I will not give you I'll spare you the details. We are preparing for a test tomorrow on Thursday. Thursday. So I'm still in review mode. The topic for tonight will be logarithmic differentiation. And I think that's what I called what we did, what the review was on the last video, but that was not logarithmic differentiation. It was differentiation involving logarithms, and it was differentiation involving exponential functions. So I went over that briefly last time, but I think I erroneously referred to it as logarithmic differentiation. It was not technically called that. Everything else was fine, but the title I gave it. So today we're going to look at logarithmic differentiation. Before we do our first one, let's look at the log rules, because logs rule. All right, here is how you take the derivative of an ln function, 1 over the expression times du dx. And here are the log rules. Multiply, you can add, divide, you can subtract, and the exponent can run down in front. These are the keys to our work. All right, keep those in mind while we set up this one. All right, write that one down, and let's take the derivative of it using logarithmic differentiation. It'll really help our work. You could do the first times the derivative of the second plus the second times the derivative of the first, and so on, but this will make it a lot simpler. All right, so y, we're going to take the ln of both sides. ln is just a special log, so log rules apply. And when I take the ln of this side, it allows me to break this down into a more manageable. Here's a product, so I'm going to do the ln of first expression plus the ln of the second expression. Let me rewrite that with, let me pan back a little. Let me write that as 1/2 exponent. 2x squared plus 3 to the 1/2. So I can use log rules there. All right. I continue to apply log rules by moving the 2 and moving the 1/2. All right, let's go ahead now and differentiate from left to right. So we have 1 over y dy dx equals 2 over x to the 5th plus 5 times the derivative of that, which is 5x to the 4th, and 1/2. So I'll put the 2 in the denominator with the 2x squared plus 3 times the derivative of this, which is 4x. All right, now we can clean this up a bit and bring the y over. This numerator combines over this expression, and this, oh yeah, the 2 here and the 4 here will combine, so I get a 2x. And the y disappears from here and appears over here. But the y, we know from the very beginning, up here, has this value. So I'll go ahead and put it in here. Now on the test, unless it's a one that is easily algebraically reduced, I'll let you stop there. This one I'll go further. I can give you extra credit if you go further. How about that? So if I was going to simplify this mess, I would go in here and give it a common denominator. So that requires me to multiply this term by that and this term by that all over the common denominator. Times and I'll write this to the 1/2 again. All right, so we have this over this times this. So this will cancel out one of these, and this I'll move down here, and it'll cause this to be 1/2. So the only thing left is for me to multiply this out, and whatever I get in here, I multiply this out. So I did all that, but I'm not going to take up video minutes to show you. And it came out to 22x to the 11th plus 30x to the 9th plus 120x to the 6th plus 150x to the 4th plus 50x. So, see if I got that. 20, 30, 120, 150, and 50. All over square root of 2x squared plus 3. All right. So the calculus on this one is not bad. It ends right there. But the algebra takes about 10-15 minutes. I'd say 10 minutes, but on a test that's too long, so I'll just leave that. If you have extra time, you can do the algebra for extra credit. All right, so we'll talk about that later. Let's go on to see what else I want to review today. I guess I'll review inverse trig. So let's look at inverse trig. I'm going to go ahead and shut down this section, and I'll be right back. Part 2 is a-coming.